Hey students, before you get this video started, make sure you have your math notebook open in front of you. You're going to take these notes on the right-hand side and use the left-hand side to do those Edpuzzle questions, entry tasks, or any other notes you take during our class time together. So the name of our section today is 5.3/5.4, which is about rates and comparing rates. So first we're going to learn about rates and then we'll talk about comparing rates. That means our first learning target 1, is I can find rates. In order to do this, we need to define what a rate is. A rate is just a ratio of two quantities with different units. For example, when you're in the car and you see the speed limit signs that say miles per hour, miles and hours are two different units, so that is a rate. There's a special kind of rate that we use a lot that's called the unit rate. A unit rate compares a quantity to 1 unit of another quantity. So for example, if I said a car drives 60 miles in 2 hours, that's just a rate because it's comparing two quantities with different units, miles and hours. But if I said that car drives 30 miles in 1 hour, because the second number is 1, because we're comparing the miles to 1 hour, that's called a unit rate. Little side note about unit rates is that equivalent ratios, remember equivalent ratios were what we talked about in the last video that we put in our ratio tables. Equivalent ratios have the same unit rate. Okay, so the first thing we'll do is a couple examples of just rate in general. So we see this number line here. This number line is a double number line that's representing the rate of points scored to notes that were hit correctly in a video game, like let's say Guitar Hero, for example. So if we wanted to write a rate based on this double number line, it would look something like this. We could pick any number of points. Let's pick 150. And we would say that you earn 150 points for every one note. So that's an example of a rate because points and notes are two different units. And this one is actually considered a unit rate because that second quantity is a 1. It's comparing the number of points for one note. Another example of a rate based on this number line would be something like 600 points for every 4 notes. Again, the quantities have different units. We're comparing points to notes, so that's why this is considered a rate. But this one is not a unit rate because the second quantity is not the number 1. All right, let's move on to a third example. This one is going to be specifically about unit rate. So let's say a piece of space junk travels 10 miles in 5 seconds. So it's going really, really fast. How far does it travel in 1 second? In other words, what is its unit rate? So if we're figuring out how far it travels in 1 second, that just means we're finding the unit rate. We're going to do that by using a ratio table again. So let's go ahead and make a ratio table where we compare distance to time. We're comparing how far the piece of space junk travels in to how long it takes to travel that far. So the ratio or the rate we were given was 10 miles in 5 seconds. But instead, we want to know how far it travels in 1 second. So we would like to turn this time value into a 1. Well, what can I multiply or divide 5 by to turn it into 1? I can divide it by 5, and that would turn it into the number 1. So to get the distance, I'm going to divide 10 by 5 as well. 10 divided by 5 is 2. So that means the space junk travels 2 miles per second. Its unit rate is 2 miles per second, per 1 second. Another example about using the unit rate, we're going to use it to determine if 2 cars are traveling at the same speed or not. So car A goes 50 miles in 2 hours. Car B goes 60 miles in 3 hours. Are they going the same speed? Or in other words, are they equivalent ratios? Well, remember earlier we said that equivalent ratios should have the same unit rate. So if we find the unit rate for each car, if we find out how far each car goes in 1 hour, we can determine if they're going the same speed or not. So for car A, comparing miles to hours, we know car A travels 50 miles in 2 hours. But we want to know how far it travels in 1 hour. So we want to turn this 2 into a 1. I can do that by dividing it by 2. If I divide that one by 2 to keep my ratio or rate equivalent, I must divide the top by 2 as well. 50 divided by 2 is 25. So that means car A is traveling 25 miles per hour. That is its unit rate. Now car B, let's make a ratio table for car B. It travels 60 miles in 3 hours. So again, I want to figure out how far it travels in 1 hour. So I need to turn the 3 into a 1. I do that by dividing it by 3, which means I must do the same on the top. 60 divided by 3 is 20. So car B travels 20 miles per hour. Now that we know both cars' unit rates, we can say that they are not going the same speed. Car A is actually going faster than car B. So these are not equivalent rates. They're not going the same speed. Now moving on to learning target 2. Learning target 2 says I can compare rates. So now we're just going to apply what we know about rates to compare two rates. Our first example is talking about some salsa that we're making. So we have a green bowl, and in that green bowl there are 6 tablespoons of hot sauce per 3 cups of salsa. And then we have a red bowl that has 12 tablespoons of hot sauce per 4 cups of salsa. And we want to figure out which is hotter. Which of these salsas is going to be spicier? Well, we can figure that out by finding their unit rates, just like we did in the last example. If we know how much hot sauce there is for each cup of salsa, we can determine which bowl is hotter. So let's start with the green bowl. We're comparing hot sauce to salsa. In the green bowl, we have 6 tablespoons of hot sauce for 3 cups of salsa. We would like to figure out how much hot sauce we use for just 1 cup of salsa. So we're going to turn this 3 into a 1 by dividing it by 3. That means I must do the same on the top. 6 divided by 3 is 2. So in the green bowl, there are 2 tablespoons for each cup of salsa. Now let's do the red bowl. Again, we're comparing the hot sauce to the salsa. This one has 12 tablespoons of hot sauce for 4 cups of salsa, but I want to figure out how much hot sauce there is for 1 cup of salsa. So to turn 4 into 1, I divide it by 4, and then I do the same on the top. 12 divided by 4 is 3. So in the red bowl, we have 3 tablespoons of hot sauce per cup of salsa. That means that the red bowl is hotter because there is more hot sauce per cup of salsa. So red bowl is hotter. Let's do one more example like this. So you're at the store and you're buying dog food, and food A, you get a 20-pound bag for $40. Or food B, you can get a 30-pound bag for $90. We want to figure out which one is a better buy. Well, we can't just compare their costs, because if we do, that wouldn't make sense because we're getting different amounts. So of course the one that you get more food is going to cost more. But what we want to know is how much does each bag cost for 1 pound? If I want to buy just 1 pound of the food, how much would it cost? That will help me determine which one is a better buy or a better deal. So food A, we are comparing the cost of it to the pounds. So it costs $40 for 20 pounds. Again, we're going to figure out how much it costs for just 1 pound. So to turn the 20 into a 1, I divide it by 20. And then I do the same on the top. So 40 divided by 20 is 2. So that means food A is $2 per pound. Now let's look at food B. Again, we're comparing the cost to the pounds. Food B is $90 for 30 pounds. I want to figure out how much it would cost for 1 pound. So I divide it by 30. 30 divided by 30 is 1. And then on the top, I do the same thing. 90 divided by 30 is 3. So that means food B is $3 per pound. That would make food A a better deal, a better buy, because it costs less per pound of food.